So I want to talk a little bit about solenoids and magnetic fields. So a solenoid is a is a coiled wire. Okay. So sometimes we represent this something like this, and they're a little bit harder to draw, but let's draw it something like this. And then there we go. Okay, so a rough drawing of a solenoid there. Now, as we can see, they're kind of curled around. Let's clean this up a bit. And there is a negative current occurring here, right? Your electrons will want to be repelled by the negative side of your battery and attracted to the positive side of your battery. Now, this is actually creating a magnetic field around this because we already know that moving charges create magnetic fields. Okay, and we've talked about that in previous videos. Now with a solenoid, it actually creates a really cool type of magnetic field that almost creates a bar magnet in a sense. Because in this case, this is going to create a magnetic field where you're going to have a north pole over here and you're going to have a south pole over here. Now you might be asking yourself, how do I know this? Well, I know this because of a new hand rule. Okay, so it's again the exact same thing. Right hand is for positive charges and left hand is for negative charges. Okay, and recognize, always remember that a conventional current, okay, note, conventional currents, that means you are talking about a positive current. Okay, so just some things to note here. So right hand positive charge, left hand negative charge. Now how do I do this hand rule here? Well, what's going to happen is your fingers will wrap around coil in the direction of the current. Okay, and your thumb is now the direction of magnetic field. Okay, so let's go back to our example here. Well, if we were to really poorly draw a hand, and this is going to be rough, guys, trust me. If we are going to draw a hand here, it's a negative current, okay, so negative current, which we know we have to use our left hand. Your fingers, now note that the electrons are coming up and then wrapping around this way and going around and around and around like this, okay, and then coming down. So that means your fingers, if you're going to be doing this along with me, your fingers and your palm should actually be facing towards your face and then curling around. So your fingers point towards your face, or not your fingers, sorry, your palm points towards face. Palm points towards face and wraps. And fingers, my goodness, wraps around coil. Okay, so really roughly, it's going to look something like this. There's one finger, very poorly drawn, and then you have another finger coming around, and then another one, and then another one. Okay, so your fingers are pointing like this, so my electrons are flowing roughly like that. And then your thumb is going to come here and then point directly that way. Okay, so your palm, this is your palm, just to be aware. Okay, and you can't see You can see all your fingernails here. Can't see your fingernail on your thumb. Okay, and that's the direction of the magnetic field. So your magnetic field would be coming through here. So there's an arrow, and then it's going to be coming around. So remember, how do I remember that? Remember, N is no thanks for magnetic fields, and S is for say yes. So your north pole is rejecting the magnetic field, so it's pushing it away, and your south pole is allowing the magnetic field to enter into the solenoid. So no for no thanks, and S for say yes. And that is the how to determine a magnetic field in a solenoid. So let's do maybe a really quick other example. Let's do it where our solenoid looks something very similar, but let's make our electrons go the other way. Okay, and then it comes around. And goes through. Okay, so in this case, your electrons would be going here and coming down this way. Okay, so let's determine which way our magnetic field is facing. So you have to use your left hand because it is a negative charge, a negative current. Your fingers are going to have to, your palm will be facing away from you, and your fingers will kind of curl away from you and then point towards you back. So the biggest thing is palm should be facing away, and then curl fingers. Okay. Now, your hand should be kind of wrapping around that coil because your electrons are going that way, right? Your electrons are coming up and curling away from you and then coming back this way. And your thumb should be pointing to the right, okay? Thumb to the right. And that is your magnetic field. Okay, so if we were to draw that, we know that our magnetic field is pointing to the right, so it's coming over here and then curling back around, coming over here and curling back around. And we know that our thumb is pointing to the right, so our magnetic field will point right, but then again, it'll curl back around and enter in. And remember, your north pole says no thanks. It rejects the magnetic field line, so this is your north end, this is your south end.